Hello everyone. My name is Kumar Gaurav
My name is Bhavishri.
and welcome back to our channel Let's Practice Together. So today in our coding challenge, we have taken one more important question which is single element in a sorted array. So Bhavya, can you read the question for me?
Sure. You are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return the single element that appears only once.
Yes, and it is a very easy question, right?
Huh.
In past you have already solved one question like find the missing number or repetitive number.
Huh.
Okay, so this has the same concept.
Hmm.
So tell me your approach, like how you are going to solve this question.
Hmm. We can solve it easily by using XOR operation
Hmm.
because in mathematics we know A XOR A is equals to 0. If we apply XOR operation in this whole array,
Hmm.
then all duplicate elements will become 0 and only the single element will be left, and that will be the answer.
Perfect. So can you implement that in the code?
Yeah, sure.
Hmm. So what you will do, you will just take a variable which you have to return. Yes,
Uh,
s equals to 0 and then simply for loop int. If you want to do for loop and you just have to use the elements, not the index, then you can simply use write like
yeah.
auto variable, so you will only get the element. So we will
Uh,
use this one only if we want to work with the elements, not the index, right?
uh,
Perfect. So auto l in nums, you can simply s
XOR
xor
equals to
equals to ele.
element.
So you will think why this has been labeled as medium level question,
Hmm.
right? So see, what will be your time complexity for the code you are writing?
Uh, Big O of n.
Big of n because it is going through the whole loop, right?
Whole. Huh.
But read the last line which you have missed while reading the question.
Okay. Your solution must run in big O of log n time and big O of one space.
Yes. And in the first line what it has written? You are given a
Sorted array.
sorted array. So whenever you will read these two terms together, sorted array and order of log n time complexity, then immediately binary search should come into your mind.
Huh.
Okay, whatever you have written that is good, correct. If you run and submit, it will work.
Huh.
Definitely it will work.
Huh.
But the time complexity is order of log n.
Hmm.
Okay, so run this one time. Let's see if you are getting the correct output.
Okay.
And then we will work in for the order of log n time complexity.
Okay.
Yes, it's accepted. So now we have to implement the binary search, right?
Huh.
Now think about the idea for binary search. What is our idea? Binary search means what? You will have some left part, you will have some right
Right.
part. Then we will
Huh.
take out some middle.
Huh.
Now our concern is to find one condition according to which we will shift our left or right to the middle plus one or middle minus one, right?
Huh.
So what will be that logic? In what logic we can shift it to the left part or to the right part? Okay, so in any
Hmm.
binary search or like the application of the binary search, we have to think this. Okay,
Huh.
now think that only for in this question, like we have to find the single element, not the duplicate elements. So
Huh.
let's suppose like all the duplicate elements are together 1 1 2 2 3 3 4 4. So what you can observe, like index will start with 0.
Huh.
So in every odd index we can say like okay, that have the that duplicate number. So
Huh.
anytime, like anytime in our array, if we got some number which is
Hmm.
in even position,
Huh.
and beside having the even position, if the right side is also same,
Huh.
okay. So suppose you can see 4, 3 and 4.
Huh.
Okay, what is the place of 3?
4.
Fourth position, which is
Huh.
even.
Even.
So if it is even, that means after that the number should be equal.
Huh.
But here the
Huh.
number are not equal, and if
It's a
both are
different.
not equal, it means what? That the single digit number is lying in the left of
Left.
the 3.
Huh. Huh.
Correct? Understood? So
Understood.
that should be our logic. Like on the what basis we will shift? If our index is even, then we will check if the right side element is same or not. If it is not same, we have to shift to the left part. Otherwise, we will shift to the right part.
Huh.
Okay?
Okay.
Okay. So whenever we will find the middle element, middle index, and if that middle index is odd, then what we will
Hmm.
do? We will just minus minus.
Huh. Huh.
Okay. So that again we can come to the even part and we can check to the right.
Huh.
So let's implement it that way. Come on,
Okay.
clear it. And let's take one left and one right.
Hmm.
Hmm. Correct. Just clear the. So you will take left. We will start with zeroth index, and right we will start with last index, which is nums dot size minus 1. Perfect.
Hmm.
So binary search means what? While our left is less than right, till then
Huh.
we have to work, because if both are equal, that means we reach to the final position.
Final position.
Yes. So let's calculate the middle. Int mid equals to right plus left by 2. But in this way calculation, you can get the overflow. Right? For the large number of right and left, you can get the overflow. So
Hmm.
always have a good practice to change this middle number, so that you will never get the overflow condition.
Okay.
Suppose right also int max and left also int max. So two int max can easily give you the overflow, right?
Ha ha.
So always think for subtraction, not for the addition. So what you will do, you will say left plus right minus left by 2. So in
Okay.
that way you can calculate, and it will be same, right plus left by 2 only.
Ha ha.
Perfect.
Perfect.
Okay. So now you have to check if the middle is odd index. No, you have to check if the mid is odd. Then
Ha
I said to shift it to even.
ha.
So how you will check odd? Yes, divisible by 2, and if it is 1 remainder, that means it is odd. So you will simply do mid minus minus. So
Hmm.
that now it is in even position, and now you can simply check to the right side only.
Ha.
So if nums of mid is not equals to nums of mid plus 1, like in this question we are getting 3 is not equals to 4. So now we have to check only left side. That
Hmm.
means our end will come to the middle part. That means right, your right will come to the middle part.
Ha
You have
ha.
written right. So right equals to mid. Perfect.
Hmm.
Else what we will do? We have to check for the right part.
Ha.
So you know both are same, like middle also same and middle plus 1 also same.
Ha.
So you will shift left to the middle plus 2.
Two.
Perfect. So mid left equals to, not plus equals to 2, left equals to mid plus 2,
Ha.
because you are shifting the left to mid plus 2, right?
Ha.
Huh. Same concept of binary search, but the condition is depending upon the question.
Hmm.
And at last what you will return? You can return anything, left also, right also, because both are same now.
Ha.
So whatever you want you can write. Okay, nums of left. Perfect. So
Hmm.
as we have implemented binary search, that means we have encountered that order of log and time complexity.
Ha.
Done. But you are getting the wrong answer. So now we will see why you are getting the wrong answer. So let's debug what you have done wrong. Output is 1 and it should come 2.
Hmm.
Hmm. Just think what you did wrong. In 8 number condition you did wrong. Like nums of middle is not equals to nums of mid plus 1.
Okay.
No, you have to check for the index mid plus 1.
Ha.
But you have added in the number only, so that was the problem.
Ha.
Correct? So now run. So yes, it's accepted and you can submit the code. And I hope you have understood the problem, you have understood the solution, and how we have come to this solution, that also you understood, right?
Ha.
So we will meet again in next question. Till then, stay blessed, stay safe, and keep coding. Thank you.
Thank you.